In order to overcome ideality of the gas phase, gas, uh, we have to introduce one factor that is called compressibility factor. Represented by Z. Z is equal to V over ideal over V real over V ideal. And if you can see V ideal, you know already is PV is equal to RT. So from here we can put V over we have RT over P, which will come out to be PV over RT. So Z come out to be in this form. So if Z is 1 for ideal gas, 1 bar, PV is equal to N RT, Z is equal to 1. Okay. And it can be less than 1, can be more than 1. So because there is no gas, no gas is in ideal state. So what we can do is we have to develop some more question that can fit to the real gas. So for the real gas, like all gases are behaving as a real gases. So what we can do is we need to develop some question of relation, pressure volume temperature relation, or we have to do some correlations. So in your course we will have two question of states and we have two correlations. So the first go for the real gas. So we have two question of states. Let's say first we can first the question of state is called variable question of state. Variable question of state has so many forms, like it has 1 plus b p plus c cap c dash prime p square, so on, and d and so on. And similarly it can also has one form in terms of volume, b over e plus c over v square, and so on. So this is the first term, this is the second term, this is the third term. Second, first, third, and four, and there is d and so on. So this is the first term, this is the second term, this is the third term. So in your exam, solve the problem using only up to three terms, or truncated your question onto three terms, then you have to use three like this. If it is for the two terms, then the question becomes like this. This is only for the up to two terms. And of course this is, if you remove this one, it will Z will equal 1, it means ideal gas. Z will become ideal gas, is for ideal gas. So you see here this B and B dash are called second variable coefficient. C and C dash are called third variable coefficient. So these are all the attractive terms that we are just adding. Okay, so this form, you can also have one more form. The B and C you can see in the book, but I can just write briefly. They can interrelate with each other. B over RT, C dash equal to C minus B square over RT square. So they can interrelate with each other. So B and C are the second and third variable coefficients. Generally C is most of the cases are negative, but the B always negative, but C can be negative, can be positive. And the another form of variable coefficient is so we have this form, we also have this form, 1 plus BP over RT. So there is another form that we need to we have to discuss also. So you see there are so many forms of variable coefficient of state, variable coefficient of state. This question is generally applicable below critical temperature, below critical condition. This is for very low pressure. Higher, if you decrease the term, so the pressure will be, the question will be more effective if it is at low pressure. So generally this question is only for gas phase one and only for low to moderate pressure. Low to moderate, so you can see the pressure range. I can write over here. Low pressure 0 to 10 to 15 bar. Moderate pressure 10-15 to 50 bar. And high pressure is above 50 bar. This question is only applicable, you see this question is only applicable for the low to moderate pressure. That's why it's not so that is only applicable for the gas phase, because liquid can sustain high pressure. The effect of pressure on liquid is very small. So this question can also be write down in terms of PV equal to R. We can say this question can also be write down as V is equal to RT over P 1 plus B over V plus C over V square. We can replace the Z by P over RT. Similarly, we can write down this question as V is equal to RT over P 1 plus B over V. Whenever we have the unknown value, whenever the thing that you have to find is on the both sides, then you have to iterate. Nobody will use solver. I will tell when we solve the problem. But before than that, we can have a look like this compressibility factor. I told you this compressibility factor can be is 1 for ideal gas and can be less than 1. I can write over here, and can be more than 1. So less than 1 means the attractive forces are dominant. Here the repulsive forces are dominant. So this is the story. So for ideal gas, generally when we solve the problem for gas phase, so far our we are getting mostly close to 1 for the gas phase and slightly less than 1. You will see when we solve the problem, but it can be more than 1 depending on if pressure is very high, they are exerting, because repulsive forces are very high, so they are exerting more pressure on the walls. They can expect more pressure. Then we have, you can see the diagram maybe in the my lecture notes. Then we can have so this is the story. And R value, I told you already, R value you can get it from the appendix A. Generally we use R for the case of volume. We are using 83.14 cubic centimeter mole bar per mole Kelvin. So these are the generally we use in order to find the volume. So you see here, whenever we have to find volume, we have to use the volume as in terms of a bar, in terms of, and the volume come out in cubic centimeter per mole. You have to use the pressure in terms of a bar and temperature in Kelvin. So let's see what we have here. We have one example over here we can solve, and we can make a picture, or we can make our picture more clear. Let's see where I have. So So we have this example. So we have ideal gas question and we have variable question. We have to solve the problem. The B and C are given. It means only two parameters are given. Only second and third variable coefficients are given. So we have to apply both. What are the reported values of the isopropyl vapor at this temperature? So the so we can just convert this one into absolute temperature, and the R value, R constant value of R is 83.14. So this is very simple. You can see over here the ideal gas is very simple. So if you solve part A, it is V is equal to RT over P, because Z is equal to 1. So we have to find both Z and V. So if we substitute the values, so in exam you must have to substitute the values and then able to solve and show me all the calculations. Okay, so if you solve, very simple, just plug in the values. If you solve the B part, variable question. So variable question, we see we have so many forms. The variable question has so many forms. So what we can do is we can use this question, because we have given the pressure is given 10 bar. So you can see pressure is given 10 bar, temperature is given 200. We have to convert into Celsius, Kelvin, and R is already given, so we can just plug in the values. So pressure is given, so it means we have to solve the problem for the volume. So what we can do is better to use this question. So we are using this question. V is equal to RT over P, 1 plus B over V plus C over V square. So we have only B and C given, so we can just stop this question up to here. So we can just plug in the values. What we can do is, here we need to do iteration. So you are familiar how we can do the iteration. You can see in my lecture notes as well, but it's too lengthy in order to solve the problem. So what we can do is we can take V ideal as initial guess. We can use V ideal as initial guess, and then we can plug in the value over here. We know R value, we know T value, we know P value. So these R value, it gives you this answer. And what we can do is, B is already known, C is already known. What we need to do is, you can take this V as a initial guess. So calculate this value, V ideal. What are the steps? You just need to calculate V ideal in calculator, save as, press equal sign, and it will save as ANS, answer. When you plug in the answer, then you have to again write all values, like this will be 473 and 83.14 over 10 bar into 1 plus B, already known. B is, sorry, I can write 388 over answer, plus minus 26,000 over answer square. So, and then after that, the question will write, you have to write the question in terms of this form. Your calculator will save your initial guess as answer. It will go over here, and then you have to keep on pressing equal sign. So in exam, you will get until you convert to a single one value. So maybe first value, if you calculate, it comes out to be, the first value that you will put, it will come out to be, of course, the ideal. So it will come out to be 3539. First one maybe come out to be 3934, but this is the ideal value. V2, then V3, let's say comes out to be 3495. V4 3488 and V5 3488. When you get these values together, both values same, both consecutive values are same, then this is your answer. So what you can do is in exam, only just you have to show me all, only you have to show me these values. Don't show only the one value. If you show only one value, it will consider as you are using solver, and I will give you the I will not give you mark for this step. Okay, so you must have to show all v1, v2, v3, and then solve the problem, then show all values. So you are already familiar with this because you already passed thermo 1, and you already know this way how to solve, and we are just revising in thermo 2. So I already told you in, this is how we can solve the problem. So once we know the v, then we can easily calculate z. So z is equal to PV over RT. So you can easily find the Z value. It comes out to be 0.8866. And here we have cubic centimeter per mole. So this is how we can solve the problem. In exam, you must have to show all V1, V2. Whenever we have to find the parameter that is on both sides, we have to iterate. We see in this case V is on both sides, so we have iterate. So we will face the same problem when we go to the cubic equation of state. And the cubic equation of state also has the same concept. So let's see the other question. So there are some drawbacks of this question. And the drawbacks of this question is this question is only valid for low to moderate pressure. I told you, only for low to moderate pressure and only for gas phase. And this problem of this question is not at high pressure, not valid, and also the problem lies in the two-phase region, because phase will change over there. So these are the two main problems, and not valid for at high pressure. So